Hello friends, welcome to Real Learning Center. We have been talking about matter around us, studying about why chemistry, few interesting reactions, kitchen chemistry and so on. In this session, let us focus on separation of materials. You might be wondering why separation of materials has to be studied. Many times we are interested to study about one main component which is the part of the matter, and we are more interested to know about its characteristics, properties and so on. So in this session, let us try to talk about separation of substances. Here we are going to focus mainly on four important techniques that we use for separation of materials. We are going to talk about filtration. Whenever I make coffee at home, I need to separate the powder from the decoction, and what I generally do is I use a coffee filter to separate the coffee powder from the coffee decoction. Now that is the filtration. Sometimes it so happens that I might not get coffee filter around me. In such cases, what I do is I would just allow that utensil to stay on its own, and after some time I am going to slowly pour off the decoction out. Now that process is decantation. We all of us know what evaporation is, and in this session we will also try to study about how this evaporation would help us to separate materials. Lastly, we will discuss about distillation process, where we try to find out about one of the most important techniques used in industries to separate materials. So let us start with some of the aspects about the separation of materials. So the first one we try to talk about is the process of decantation. Now right in front of me you can see various beakers, each one having one or the other substance. Right in front of me I have milk, and if you can carefully see, I can see a layer of cream floating on that. When I boil milk, there is no creamy layer. When I cool it down gradually, I see that the fat which is there in the milk will get separated out on its own, and that is what we call as cream. Now, how do I separate cream and milk? Very simple. Very slowly I just take the milk dish, slowly pour it out, and the milk flows down and the cream remains in the dish itself. Now this process of simply pouring down very slowly is what is called as decantation. In another beaker I have the water with some dirt. You can see that the dirt has formed a layer at the bottom, and the water is floating on the top. Many times this is a very important method to separate solid substances, solid waste from sewage water. This is called as decantation. I am sure when we give blood for analysis, what they generally do is they collect the blood, put it into one test tube glass container and allow it to stand for 2 to 3 hours. When you do that, you see that all the blood cells would be at the bottom of the glass test tube, and the fluid part of our blood would be floating on the top. So this lower region is having all the red blood cells, and the upper region, which is not having the red blood cells, is called as plasma. A very important technique to separate blood and plasma is decantation. In fact, many of our diagnostic procedures are based on the separation of the blood and plasma. The last one which we have right now is a mixture of oil and water. You know that oil and water do not mix with each other. And when they do not mix with each other, you see that water will always be at the bottom and oil will be floating on the top. Now this way I can separate water from oil by simply pouring it into another dish. Now if you have noticed all these 4 beakers right in front of me, you see that each of them is not mixing with the other readily. Now such substances are called as immiscible substances. Now to separate immiscible substances, decantation would be the best. It would be the best procedure to follow when their masses are slightly different. Okay, milk is heavier than the cream, so when I pour it, milk comes out first. Water and dirt is heavier, so it settles down. Blood and plasma, blood cells are heavier than the plasma. In a similar way, you see, water is denser than oil. So decantation is a very simple process to separate 2 immiscible substances. The other substance that the other technique that we see now is a process called as filtration. Now whenever I have to separate solids and liquids, we use this filtration. So I have a coffee filter here. You see that coffee filter has small holes present in it, which we call as pores. Okay, the pores are so small such that they do not allow the coffee powder to pass through. However, it allows the decoction to pass through. So in a coffee filter, we see that there is a mesh which allows the liquids to pass through, but the solid coffee particles are in the filter itself. Now this same technology is used even in our air conditioners. You know, in air conditioners, we do not use water, but we use another fluid like a gas. The gas or the atmosphere here would have very fine solid particles which is filtered by the mesh that is seen in the air conditioners. This way the air is filtered from an air conditioner. This is widely used in our laboratories as well. What we do is we take a small funnel, and into this funnel we are going to put a paper which has a very specific pore size. I am going to fold it, put it into the filter paper, and then the liquid that has to be filtered, I am going to pour it into this. All the solids would be collected in the filter paper, and all the liquid which is poured down is collected in the flask kept below the funnel. So this way we can use filtration to separate solids from fluids. You know, this process is occurring every day, every minute in our own body. That happens in kidneys. Because of various processes happening inside the body, our body produces toxic wastes. Now these toxic wastes are to be sent out of the body, and our kidney does the same work as any of these filters. The blood is filtered, all the part of the blood which is required by our body is sent back to the body, and all the wastes which is not required by the body is filtered and is sent out of the body in the form of urine. So filtration is a very important separation technique. The next process is evaporation. We all know what evaporation is, and in this sessions we will see how this evaporation can be used to separate soluble solids and liquids. This technique is widely used in salt making. How do they make salt? How do they make salt? It is made by a very simple process by making sand bunds. The sand bunds are made into which the ocean or the sea water is poured, a very thin layer of it of course, and due to evaporation, the water evaporates, the sea water evaporates, leaving behind the salt. This salt is all collected, dried and put it into packets and sold. And this is the salt which we consume as rock salt. Another process where evaporation is used is in printing process. Whenever you have a printed paper in front of you, you can always say that it is because of a process of evaporation. What you do here is you take the substrate. The substrate is any substance onto which you want your printed things to be appearing. It can be a paper, it can be a fabric. So you take this substrate, and onto this substrate, you are injecting the dye. Now this dye will fall on the substrate. As soon as it falls on the substrate, you see that it spreads and fuses. Allow it to stay for some time. The solvent dries and the dye which was used in our ink, would be attached onto the substrate. So this way, evaporation is used in the printing process. In a similar way, it is also used in coating process. Here again, the substance which has to be coated, we call it as substrate. Okay, we call it as substrate, and onto this substrate we very finely put in some spray. Okay, just like how we spray the paint, we have some spray which can have metals or ions or many things of that kind. So I am going to put a very thin layer of metals or ions or the dye, and then what we do is we see that these droplets which are coming from a spray which we call as atomizer, in chemistry. So these would kind of clog together and would form a thin layer on the substrate. It would form a thin layer on the substrate. Now this thin layer on the substrate, when it is not disturbed, you see that it would form a very thin solid film on the substrate. So this way evaporation is used in coating process as well. Evaporation happens in nature. You would have studied that when you have studied in water cycle. This evaporation happening in plants also sometimes you see that helps the plant to survive by absorbing nutrients. We all of us know that there are roots in the plants which will absorb water, and the water rises up to the plant mainly because of transpiration. Whenever the plant is absorbing water from the roots, you see that it is not the pure water that it evaporates. It will absorb all the nutrients, all the minerals from the soil, and it is taken up by the plant, and when it is moving up, the plant uses up all the nutrients and all that, and in the process of transpiration, only water is sent out of the plant system. So this way, evaporation leads to transpiration in plants, and this in turn helps the plant to get nutrition and various minerals from the soil surface. A similar process occurs even in humans. Whenever we do a lot of physical activity involving, a lot of muscle activity, what happens is that there is increase in body heat. The body heat increases. Now this sends a signal to the hypothalamus which is in our brain, a small region in our brain called as hypothalamus. This heat sends a signal to hypothalamus, and that stimulates the sweat glands to secrete fluid out of the body. And our skin has small glands which we call as the sweat glands, and these sweat glands becomes active and they send out all the fluid from the body, and that actually cools our body. Now this is how we sweat. So the basic process of sweating leads to cooling the body. But along with this, there is also one more important function caused due to sweating. Skin throws out most of the waste produced in the body in the form of sweat. Whenever sweat comes out of the body, it is not just water, but majority of the toxic wastes produced in the body also comes out through the skin. In fact, it is estimated that around 50 to 60% of the dust we see at homes is having shredded skin and toxic waste. This way, evaporation leading to sweating is also helpful to throw out waste from us, from our bodies. Is it not interesting? Let us now learn about the technique of distillation. Now, what is distillation? Now, this is one technique widely used to separate miscible fluids. Suppose there are two liquids or two gases which are mixed together, completely miscible with each other, and I need to separate them. Distillation is one of the best techniques that I would use to separate them. How would I do this? Now, that is done by a very simple mechanism. I would take the fluids that has to be separated in one round bottom flask, and what I would do is I would boil it, give it some heat. When I give it heat, you know that there is boiling point of a liquid, and if the boiling points of the liquids which are present in this round bottom flask are different, the liquid which has the lowest boiling point would be evaporated first, and when it gets evaporated it becomes liquid and will be occupying the top of the round bottom flask, and hence will be moving into the tube there and gets collected in the beaker. The one with a higher boiling point would remain still as the liquid itself, whereas the one with the lower boiling point would become vaporized, would get cooled also, and gets collected in the beaker. This way, to separate miscible fluids, we are using the difference in their boiling points as the key source to separate them into their constituents. This is a very important and very interesting technique used in various industries. One of the industries which uses this is when we need to distill fermented products. You know that whenever we have a fermented product form, there is always formation of alcohol or one acid. Now, if I have to separate alcohol and water, we go for the help of distillation. The fermented products would be collected in this round bottom flask and it would be heated. Ethanol, which is a product of the fermentation here, would have a boiling point of 78.37. Therefore, it would become vapors first. And once it vaporizes, it would go to the top of the round bottom flask, and as it goes, there is an outlet there through which it passes out. This is later condensed, cooled, and is all collected in the conical flask. Therefore, if I am just maintaining the temperature of this round bottom flask below 80 degrees, all the ethanol would melt and would be evaporated, cooled, and can be collected. Whereas water, since its boiling point is 100 degrees, it would still remain in the round bottom flask itself. This way, I can very easily separate the products of fermentation. One more area where we use distillation to separate the products is in the fossil fuel industry. You know what we do here? The products, the fossil fuels are all collected, and we all know that the fossil fuel is not just one, but that it's a mixture of so many components. Some of them are gases like propane and butane, some of them are like the petrol and the diesel, the liquids, and some of them would be the coal. Now I need to have a technique to separate all these components. For that, what I would do is, I would go for a technique which is called as fractional distillation. I take all the components, the mixture of the petroleum products, I put that in one of the canals here, and then in a large tube, I would start heating it. Now this heating is all brought about at different fractions. In this column, in this entire column, this column has different fractions, and each fraction would have a different temperature. The top portion of the column would have a very low temperature, whereas the bottom of the column would have a very high temperature. Now since all the products are put at the bottom here and they are all given heat based on differences in their boiling points, what you see is, you see that they get separated into different fractions. And when they get separated into different fractions, I can collect them separately. And use it for various purposes. So this is called as fractional distillation. You can always think, why we don't do the other way around? Why can't I keep a higher temperature at the top of the column and lower temperature at the bottom of the column? Think about why it would not be a very feasible method. Once we have studied about these two techniques, let us study about one more technique which is called as the cryogenic distillation. Now this distillation is quite different from the other two types of distillation that we have just studied. Cryo means cold. In both the previous techniques we studied, we were giving heat to the column, to the distillation unit, and we were separating the products. Here, instead of giving heat, we are removing heat, or in other words, I am cooling the entire process, and in the process of cooling, I am trying to separate the components of my mixture. Hence, we call this as cryogenic distillation. This is widely used when I need to separate the components of air. As we all of us know, air is a mixture of gases. 78% of it is nitrogen, 21% of it is oxygen, and 1% of it would be rare gases like argon, krypton, and also carbon dioxide. Now, if I need to separate oxygen, nitrogen, and argon from this mixture, what we would do is we would go for a cryogenic distillation. Here, all the gases which has to be separated is taken in one small container, and it is given a very high pressure. When it is given a very high pressure, okay, we see that there is a drop in temperature, because of which some gases would liquefy. The liquefied gases are separated and the non-liquefied gases are again further processed to get various other gases. This is the best way to separate oxygen, which liquefies at around 183 degrees, minus 183 Kelvin, and then we have nitrogen which liquefies at minus 196. So differences in their temperatures at which they liquefy is what is the nodal point here for distillation. Basically, when we are focusing our studies on the differences in their boiling points as well as the melting points, and we are using that to separate out the techniques. We call it as distillation. So we have studied about various methods of separation of materials, finished with what is decantation, filtration, evaporation as well as distillation. This finishes our sessions on matter around us, where we finished talking about why we need to study about chemistry, various reactions happening in the kitchen, call it as kitchen chemistry, various colorful and beautiful chemical reactions, the interesting reactions, different states of matter, which is a very important aspect around chemistry, and we discussed about the separation of materials. So children, we will again see in the next class with various other topics of chemistry. Thank you.